In this video, we will see one application of a section formula and then end this section giving 3 quizzes to see more applications of section formula. So let's start. If you have a triangle ABC with position vector as alpha vector, beta vector and gamma vector, then prove that the centroid of triangle ABC is given by alpha vector plus beta vector plus gamma vector by 3, where centroid is defined as a line segment from a vertex to an opposite line which divides the opposite line in an equal ratio. So we'll see how to prove this. And okay, let's prove the section formula, right? So the centroid of a triangle, which is basically a line segment from a vertex which divides the opposite line in an equal ratio. So BP is equals to BC, AR is equals to RC, and AQ is equals to QB. Point O is congruent, that is all of these 3 lines meets at point O. Centroid of triangle is congruent, but we're not going into detail to prove that. We're assuming that they will meet at a same point. So let's prove using a section formula. So what is the position vector of P? Position vector of P using a section formula, which is BP is equals to PC, is beta vector plus gamma vector by 2. So to find position vector of AO, we would need to find AO by OP. If we know this, we can easily see, we can find out what is the position vector of O. So how to prove this? So position vector of R is alpha vector plus gamma vector by 2. Position vector of Q is beta vector plus alpha vector by 2. Okay. Let's consider QR. What we will prove is QR is half of BC. That is, QR magnitude is half of the magnitude BC and QR is parallel to BC, right? So let's see QR vector is equals to position vector of R minus position vector of Q, which is alpha plus gamma by 2 minus beta plus alpha by 2, which is gamma vector minus beta vector by 2, which is nothing but half of BC vector, right? So what does that mean? QR is parallel to BC. QR is parallel to BC. So this angle is equals to this angle, let's say angle 1. This angle is equals to this angle, so angle 2. So this angle is equals to this angle. So let's take a triangle OQR and triangle OBC. By sine law, we can say sine of angle 1 by OQ is equals to sine, let's angle 3, sine of angle 3, this is angle 3, by QR. In this triangle, you can say sine of angle 1, triangle OBC by OC is equals to sine of angle 3 by BC. So nothing but sine of angle 3 by twice of QR. This is equation 1. This is equation 2. If I divide the equation 1 by equation 2, what I would get is OC by OQ is equals to 2. So we have just proved that OC by OQ is equals to 2. Since all of these triangles are similar, we can safely say this also means OA by OP is equals to 2. And therefore, position vector of O is equals to 2 times position vector of P plus position vector of A upon 2 plus 1. So if I substitute this value here, the position vector of A is nothing but alpha vector plus 2 times position vector of P is beta vector plus gamma vector divided by 3. So that is nothing but position vector of A. Thus we proved that using a section formula, if we know the position vectors of vertices of triangle, which is in this case alpha vector, beta vector and gamma vector, then position vector of a centroid of a triangle is given by alpha vector plus beta vector plus gamma vector by 3. Great. Let's see some more application of section formula. So I'm going to give you 3 questions as a quiz which you need to solve. We would have a solutions in the subsequent videos, but however I would encourage you first to solve that quiz, and all can be solved using a section formula. So let's start. Okay, so if you have a triangle ABC with position vector as alpha vector, beta vector and gamma vector, and sides, length of the sides given by A, B and C, then prove that 1. Position vector of in center of a triangle ABC is A alpha vector plus B beta vector plus C gamma vector upon A plus B plus C. Position vector of orthocenter of a triangle ABC is alpha vector 10A, which is this angle, plus beta vector 10B plus gamma vector 10C divided by 10A plus 10B plus 10C. And position vector of a circumcenter of a triangle ABC is alpha vector into sine 2A, which is twice of this angle, plus beta vector sine 2B plus gamma vector sine 2C upon sine 2A plus sine 2B plus sine 2C. Just to give you an incenter of definitions of these three terms, the incenter of a triangle is where the angle bisector meets. So if there is an angle bisector of angle A, angle bisector of angle B, and angle bisector of angle C, they meet at a point which is called incenter of a triangle. The orthocenter of a triangle is if you draw a perpendicular from A to line BC, B to line AC, and C to line AC. So a perpendicular from vertex to an opposite side. The point where they meet are called orthocenter, and a circumcenter is basically if you bisect the line BC, perpendicular bisector of line BC, perpendicular bisector of line AC, and perpendicular line of AB meets, that point is called circumcenter of a triangle ABC. Again, I will encourage you to prove these before seeing the solutions in the next video, and second formula would be helpful in order to solve this.